Biodegradable and renewable packaging materials are very, very important today in designing packaging. So in order to design your packages, it's not just enough to create a package that corresponds to the function of the project, of the product that you are creating. Rather, it has to work with the environment, it has to work with the economy, it has to address resources, what resources you can use, and also aesthetics. So there's a big balance here, and it is a new time, it's a new era, so there's a lot of new things that we're trying to experiment. A lot of the technologies don't exist as good as it does with the traditional packaging and traditional materials, but then there are a lot of other good things that are available, and because there's a big push in the complete economy to do this, a lot of new changes will be happening. And I am very open, very excited to see what you will actually find in your research. This is only the tip of the iceberg. This is only part of what's going on in the market, and I like to see what else you are going to find through your research with your group project. Composting is the decomposition of biodegradable organic matter, and this can be divided into home composting and also industrial composting. And biodegradation is the process of materials degenerating through the use of oxygen and natural materials such as sunshine and water. So biodegradable materials are derived from plants, animals, and other living substances, or they are artificial materials that can be decomposed by microorganisms. And here's a little chart just to get you to understand what's really happening when you put trash in landfills. If you throw away banana peel, it takes 2 to 10 days to decompose. Maybe paper will take 2 to 5 months. Rope would take 3 to 14 months. Nylon fabric would take 30 to 40 years. And leather shoes would take 25 to 40 years. And diapers take 500 to 800 years. Could you imagine? So there are certain things that we really want to make sure they decompose a lot faster than they do right now. There's another process of biodegradation, which is the anaerobic biodegradation in a landfill. And that means it happens without the presence of oxygen. And when that happens, the byproducts are biogaz and lignin and cellulose fibers, which cannot be broken down by microbes. Now, you would say, why would you want to do such a thing? There are advantages here because biogaz contain methane, which has approximately 21 times the global warming potential of carbon dioxide. So in modern landfills, these biogaz can be collected and used for power generation. So what cannot be decomposed may actually contain energy that you can take and use in other purposes. And the engineered landfills are designed with liners to prevent toxic materials seeping into the surrounding soil and groundwater, and that is how they capture that energy and they put it to good use. There is such a thing called biodegradable plastic. And biodegradable plastics are plastics that will decompose in the natural environment. And bioplastics components are derived from renewable raw materials. Biodegradable plastics have different characteristics. The advantage of them is that in the proper conditions, such as sun, moisture, oxygen, and so forth, they can be digested by organisms. This reduces problems with litter and reduces harmful effects on wildlife. Now, the main disadvantage with oil-based biodegradable plastics is that their degradation may contribute to global warming through the release of carbon dioxide. But as we talked about, that actually could be used in an advantage too, because that could be taken and used as energy in a different way. Another disadvantage with biodegradable plastic is that it happens very slowly. The degradation happens very slowly in a sealed landfill. Also, these plastics cannot be mixed with other plastics. So that is a disadvantage, because when you are recycling, it damages the recycled plastic and reduces its value. So there are some downsides, but I think if handled well, it's really not such a bad thing at all. Materials such as polyhydroxyalkanoate, which is PHA, are biopolymers and are completely biodegradable, fully biodegradable plastics. And they are more expensive, partly because they're not widely enough used. But I think as the times will change, a lot of these things will change too. But I think it's really nice for you to just have an idea of what's the difference between biodegradables, how it gets composted with oxygen, without oxygen, and what are the materials that are available. Plastarch material is another material, PSM. It's called PSM. It is also biodegradable. It's created by use of cornstarch, modified cornstarch, and it has heat-resistant properties. It is stable in the atmosphere. As you see, you can use it to create the utensils, plastic utensils. It is biodegradable in compost, wet soil, fresh water, seawater, and it is currently used for a wide variety of applications in plastic markets, such as food packaging, utensils, personal care items, plastic bags, temporary construction tubing, in industrial foam packaging, industrial and agricultural film, window installation, construction stakes, and horticulture planters. And because PSM is derived from a renewable resource, which is corn, it has become an attractive alternative to petrochemical derived products. And unlike plastic, PSM can also be disposed of through incineration, resulting in non-toxic smoke and a white residue which can be used as fertilizer. Compostable and biodegradable bagasse carry-out food containers. This is disposable, compostable, and biodegradable carry-out food containers and clamshells. They're made out of 100% bagasse, which is sugar cane fiber, remaining after extraction of juice from the sugar cane. Sugar cane is not only a readily renewable resource, but the sugar cane fiber can be turned into products normally made from plastic or paper, and it avoids pollution from normal burning of sugarcane pulp after juice extraction. So it's soak-proof, it has no plastic or wax lining, and it can be used for both hot and cold items. Now the hot items will cause perspiring, so on the bottom of it, it's going to be a little bit wet. But it is a far superior alternative to styrofoam, plastic, and paper takeout boxes. Now, these compostable clamshells will biodegrade with 30 days in a commercial composting facility and within 90 days in a home system. So they are actually pretty well designed. The last one I want to talk about is NatureFlex films. These are based on renewable resources such as wood pulp from managed plantations. They are used in confectionery and bakery packaging. It has varying degrees of moisture barrier for hygienic application. It includes very good dead fold and excellent transparency and gloss. So it looks really good. I mean, you know, if you think that you cannot use plastic, guess what? You can. And there's all kinds of films and plastics that are biodegradable, and you know, you can use them for many different purposes in terms of recycling. And these films are proven to be suitable for home composting and will also biodegrade in a wastewater environment.